What about 64? 64 in which section? Number 64 for 7.2. Well, let's look at that one.
I had a question about 43.
43 on 7.2? Okay. So let's take a look at 7.2. All right, so 64, that's our tangent theta plus secant theta equals 1. 7.2, number 64. And that should be a solve on the interval. I think. Let me see. 2. So we're on solve on 0 to 2 pi. So that's what we're looking for. We're looking at our unit circle. What the heck should we do? Sorry, I didn't realize it was zooming in when I was writing stuff. You can. Like, not gonna hurt you. Yeah, let's try and switch these to sines and cosines because I got too many different things here. Like, this is gonna be tricksy to put together. So my thought would be to switch these to be sine and cosine. So we know that this is sine theta over cosine theta plus secant is 1 over which one? Cosine. Thank you. Equals 1. I've got a common denominator here. So we have sine theta plus 1 over cosine equals 1. We see a couple of options from here. One is harder than the other, but both work. What's your instinct? Absolutely valid. Multiply both sides by cosine, and that means we're trying to figure out when sine of theta plus 1 equals cosine theta. So if you do it like this, you're going to kind of be logicking our way through our answer here. Because think about our unit circle. This interval is the unit circle. Where are we going to have that our sine of theta plus 1 is the same as cosine? What does our sine have to be in order for that to work? 0. Our sine of theta has to equal 0. Where does sine of theta equal 0? So our only options for theta here are going to be on 0 and pi. What is our cosine at 0? Cosine of 0 is 1. What's cosine at pi? -1. So which of these has our sine of theta plus 1 equal to our cosine? Only the top one, only 0. So you don't necessarily have to make it so that we algebraically solve things. We've got it down to a few choices here, and this one doesn't work. So theta equals 0 is our only answer. That's smushed together. Yeah, you can subtract 1 and get it to equal 0. It's going to be harder, though. You could do it as sine theta plus 1 over cosine theta minus 1 equals 0. And you'll be getting yourself to our common denominator. We're going to have our sine of theta plus 1 minus cosine theta equals 0. And we're still like super unpleasant here. It's doable. It's just really not pleasant here. Because we have too many different pieces. Honestly, I've never been able, like, I've not worked it this way before, so I'm kind of making it up as we go. All right. So you can do it this way, where we have our sine theta minus cosine theta plus 1 over cosine equals 0. It's going to get us exactly back to where we were on the other one. So honestly, I'm not sure if there's a way you can algebraically get through it. That I'm not seeing one off the top of my head. I think this is kind of going to be the way we go through it, since we're on the interval and we're looking at our unit circle anyway.
Why would sine have to be 0?
Because we're on our unit circle, we're in this interval here between 0 and 2 pi. This has a radius of 1, like our unit circle is. That's why it's called the unit circle. So we know that the biggest value we have is 1, and that happens on our quadrantal angles here. So we have our 0, 1, our 1, 0, our negative 1, sorry, 0, negative 1. I'm good at writing things. And our negative 1, 0. I never have a time when I could have cosine equal something bigger than 1. Cosine has to equal 1 here. I don't have any time when cosine's bigger. So sine has to be 0, cosine has to be 1. It's the only way that this makes any sense here. So we kind of have to just look at it and say, well, if I know that cosine has to equal sine plus 1, cosine has to be 1. There's no other value that fits here. If sine was pi over 4, then my sine being square root of 2 over 2 plus 1, I'm outside the unit circle. It doesn't fit. So it has to be that cosine equals 1 because we're on the unit circle here. So it's kind of awkward and weird, and doing it this way is very unpleasant, and I think we'll get you back to the same exact spot where we have sine plus 1 equals cosine theta. It's unpleasant, but it's a thing. All right, I know we had other ones. What was another one that we wanted to do?
43.
43 on 7-2?
Yes.
So 43 on 7.2. Okay, 43, that's another one on the interval. And we've got our cosine of 2x minus pi over 4 equals 0. What's our instinct on this one? Because this is icky. We can't do that. So if we have something that's gross and we don't know how to deal with, what could I replace this with? Do a u substitution. Whenever we have something inside our trig function, do a substitution. We're going to have u equals our 2x minus pi over 4. That whole statement. Because we want to know when cosine of u equals 0. When does u equal 0? U would need to be pi over 2 and 3 pi over 2. Because cosine has to equal 0, right? Since we did a u substitution here, we're always going to, whenever we have a u substitution, we always treat this like they're asking us for all possible answers, even if we're only looking on the interval. So what do we need to add at the end over here? Plus our 2 pi n, because we got to get those coterminals. So whenever we do a u substitution on these, we're going to do the whole thing like they're asking us for all possible answers before we get to the end and we make a list. Because when I substitute my u back in, we need to be able to solve for it, and that's going to give us some kind of funky coterminal situations. Because it's not that our angle is going to be pi over 2 plus 2 pi n. It's that we have our 2x minus pi over 4 that equals the pi over 2 plus 2 pi n. So we substitute it back in. And we want to solve for x. We're just going to look at this one side for right now. What do we do to get our x by itself? Add pi over 4. I'm going to do it in a couple of steps. So we're going to have our 2x. If I add pi over 4, what are we going to have? Yeah, it's going to combine with this guy, with our pi over 2. So pi over 2 plus pi over 4 gives us 3 pi over 4 plus 2 pi n. And then we're going to divide by 2. We're going to get our x equals by 2. So we're going to have 3 pi over 8 plus pi n. So specifically, our values that are going to work here, and if it helps, you can write them with common denominators, where we have our 3 pi over 8 plus 8 pi n over 8. Sometimes it helps so that we can do that math a little bit easier, because our options for x that are on our interval from 0 to 2 pi are going to be our 3 pi over 8 and 11 pi over 8. I was like, if we add another 8, we'd have 19 pi over 8. Is that in our interval, though? So that's where we stop. Then we do the whole same thing on this side. So I'm going to take and substitute back in my 2x minus pi over 4. That was aggressive. Equals our 3 pi over 2 plus our 2 pi n. Same vibe. We're still going to go with adding our pi over 4 to both sides. So we're going to have that our 2x equals, we're going to have 7 pi over 4 plus 2 pi n. And then same vibe, I got to divide everybody by 2. And we're going to get that our x equals 7 pi over 8 plus our pi n. And again, if it helps, you can rewrite it with your common denominators. You don't have to, but for some of us, it makes the mental math way easier. Plus 8 pi n over 8. Like, I genuinely do not care if you write that step or not, but for some of us, it's really, really helpful for writing it out. Because our other options for our angle are going to be what? 7 pi over 8 and 15 pi over 8. Because after that, it would be more than 2 pi, so it's no longer on the interval. So 7 plus 8. 7 pi over 8 plus 8 pi over 8. So we got 15. Okay. So they're awkward and weird and a little long and kind of annoying. More questions on this one? Okay. Any more that you guys want to do? 7-1 or 7-2. Because our quiz is tomorrow for 7-2, which is all of our solving stuff. Okay. I know. Like these things, yeah. This is solving. That's what 7-2 is the solving.
No verifying anymore.
Well, verifying will still come back into play every now and then, but like 7-2 was the section on solving. The quiz is on 7-2, so it's all the solving stuff. So this kind of stuff.
Can you explain number 2 on the quiz?
Oh, yeah, I mean, to be fair, on the 7.1 quiz, for the most part, you guys did really good on it. It was like little tiny mistakes that people were making on it.
Right.
Yeah, I was gonna say I have them to grade it. If you want to see them, you can't. You can't keep them until I get everybody to take it. And I got a couple that are missing still. So I named none names. I was gonna say I put absolutely no one on the list.
That wall of shame is the one.
I put them on the wall of shame so that we all remember that we need to take it. Because if I don't put it up there, I also forget.
You should change the name to Wall of Shame or like a brand new.
To be fair, it's just assessments. I don't put it up there for like missing homeworks.
You should. Everybody's name. No.
I would be writing forever. All right, if you want to see your quiz, you guys can see it. Like I put feedback on it. Okay, you just can't keep them because I need them back.
No, you have to look. You got 100?
I think I got an 18.
Oh, birthday.
Justin got a 7.
Zion.
wrong?
What?
Yeah. It was just mine. How many points was it?
Each question was 4 points.
Each question was 4.
Each question was 4 points.
Take it from there.
And then what was the other one missing?
DeAndre. Emma. David. Thank you. Thank you. Thank you. Thank you.